Good morning. Today's talk is about what we can do with our new Clang compiler. Our compiler team built or bolted Clang into OpenVMS. That gives us a lot more options than some of the legacy compilers we had. So basically, we want to use new tools to make us more productive. And C++ has some wonderful features, better libraries available. So about me, I started programming in 1987 in New Zealand commercially. I've had 20 plus years on OpenVMS and over a decade with C++ and Linux. I'm now working back with OpenVMS and have a wonderful set of skills where I can bolt the old and the new together. And I'm working for professional services in Christchurch. So that means that we can help customers with their applications. We've one customer in Kansas, their program's retiring, and I'm taking on a 1980s SCADA C system. So our Clang compiler currently supports up to C++ 14. That's a quite reasonable modern standard. I'd be a lot happier if we could bolt in some of the C++ 17 standard libraries. Hopefully the compiler team will get there at some point soon. Today we're going to talk about using some library software to create a REST API interface. So in simple terms, you have on the outside, you can bolt in a web application and you can connect it through to your OpenVMS legacy library functions. And it's quick and easy to do with this technology. Traditionally, 30 years ago, we had green screens, 80 by 24 characters and terminals. And today's modern users don't want to be using green screen technology, be it through a terminal emulator. And this is a way we can improve your old applications. So for the demo, I chose a few open source libraries to help me do the tool because we want to reuse good libraries. We don't want to sit there and code HTTP server for 6 months. It's not productive. So I chose Neil Lawman's JSON parser. It's something I've used in the past. It's a wonderful tool. It's much better than the JSON-C that we currently have available with OpenVMS install packages. I grabbed a product that's new to me, which is a schema validator. And the schema validator is there to make sure requests we get contain the right fields. And I also grabbed a HTTP server off the internet. A Japanese guy called Yuzi Hiroza built this library. Again, this is a header-only library, so I can just copy the header files onto an x86 system and I can build my application. It was really easy and it was really quick to do. And in the middle, I've bolted in a class that does a C++ adapter pattern. And we get JSON input. JSON is JavaScript object notation, and it's a common protocol used with internet applications. So it's the one I chose to speak. And I translate that and I can call a legacy OpenVMS function. And it all bolts together. So let's step through and look at some of the code we've done. So here I did a nice example Fortran function. It could have been written in the 1980s. And it's just simply converting temperature between various scales. And that's the example we're going to expose to a web API interface. Everyone happy with this? Any questions? Anybody know Fortran? So it's a very simple example. Hopefully it even converts the temperature correctly, if my maths is correct. So this little block of code is our HTTP server. It's maybe 30 lines. We include a few header files. I disabled or commented out the SSL because SSL 3 gave me some challenges when I was trying to configure a self-signed certificate. But it does support SSL. It will support authorization plugin. So it's quite a useful little tool. And in a block of 10 lines, we actually have a server running. And it's the sort of library software I like. It does something easily and quickly, and it saves me time. So, and again, this is some of the power of the C++ compiler. It allows you to use powerful libraries and do stuff quickly and easily. So here we're starting to declare the temperature adapter class. We have a JSON libraries included here. We have a little helper function to help us translate strings in C into string descriptors as per the legacy Fortran. Any questions? Just shout if you've got questions as we go. So here, again, this is the temperature adapter class. That was a header file. And here we're actually declaring our schema, so that any request I get in from a web service is validated through the schema. And that tells us, for example, our input scale, you give me Fahrenheit, Celsius or Kelvin, otherwise all bets are off, and I'm going to return, you have an error, you haven't given me the right data. Again, the output scale, we enforce the same set of requirements, and the temperature you want converted, it's got to be a number. So that this saves time later, in that when we come to the real code, we have good data. This is just going very quick. So here's a constructor. Again, very simple. We set up our validator, and this is the power of the library. The C++ does stuff for us. It would take me a lot of work to do it in C. And here we actually have, this is where the magic happens. We're processing a request we've received off the internet. The first thing we do is we try and parse our JSON syntax. And we'll throw an error if someone sent us something that's non-compliant. It's as simple as this. And then we try and validate our grammar with our schema. So do we have an input temperature? Do we have a number? Do we have a good scale? If not, we throw an error back out to the client, and then we can read some data. We can read some data in from JSON, and the syntax is fantastically simple. If you've ever used JSON-C, you'll know that to get any data out of JSON string, you have to manage memory, you have to do quite a lot of work. This makes your life much simpler using a new library. So For me, it's my preferred go-to library if I have to do anything with JSON. We've got some stuff in. We're making some string descriptors here. We'll need those when we talk to Fortran. And so we call our actual Fortran function here, convert temperature. And we check errors, we build a JSON response, and we can throw it back. And so the code has a few features. You'll note that the function names and the variable names are all pretty much self-documented. So that means that if somebody else comes in and has to maintain this code in a year, or even if I come back and I've forgotten what I've written, hopefully I can understand this quickly and easily. The code should be simple to understand by anybody. We shouldn't have obscurity in what we've written to try and confuse people maintaining it. So that's the magic. We have a complete program. And obviously, we want to test what we've done. You can use whatever web technology you like to connect, whatever product your corporate manager loves. We can use that flash fancy internet technology to connect as a client. I'll put together a little Python client, which will see the results on the screen. It's given us out a resultant temperature. We can also test our schema validator using curl, and we can test our JSON parsing. So, any questions? So, at this point, we can sort of have a sum up of what this little demo's achieved. We pulled in 3 libraries. We gave them a test and experiment, and we found that the JSON library and the schema validator have worked very well. The HTTP lib comes with a few qualifiers. It's a well-supported product and it builds, but firstly, it uses blocking I/O. So if you're going over 50 or 100 clients, you might have scaling issues. And secondly, it uses threads to run multiple parallelization. And we have some issues with that if we talk to Fortran code, because the VSI Fortran library or the VSI COBOL runtime are not going to play very nice with a threaded application. You're going to get race conditions, potential access violations, or other undefined behavior as per C++. So we can use the Web Service Integration Toolkit. This is a tool Brett talked about yesterday to run the HTTP server for us. And it has an option where every little client process, every worker process sits individually in an OpenVMS process. And all of a sudden, we've solved any threading issues we have in our runtime libraries. And so we take a multi-thread, multi-process server that WSIT can give us. We bolt it into our adapter class, which uses our JSON libraries. And say, it's like I might have got the wrong version here on the screen. Basically, we should be able to connect the Web Services Toolkit with our adapter and our Fortran function, and we can have any legacy application we can have users inputting via a web screen. And the key benefit here with our compiler was this has been extremely quick and easy to put together, and extremely quick to talk about. You get a right. For the purpose of the demo, does anyone have any questions on our web server? Is it all nice and easy?
So your your JSON parse or the thing that was checking, it only I could only check the first missing parameter, and then on the first one that's not there, it doesn't stop. I think that's the last page you have
Which one was this?
right there. 3/4 of the way down. Target property in scale not found. But it looks like you didn't pass any parameters. I mean, is it only checking for the first failure? And then
It's reporting the first error is found. So it fails fast and it reports an error. It's not like a compiler where it runs through everything and reports a big list of errors. The thing that's important is that it either passes or it fails validation. And if it fails, you want to handle it as an error condition. And if it passes, you want to forward it onto your OpenVMS functions and let your existing library code work. So we don't want to be bothering library functions, calling them with nonsensical data. We want to make sure that we've received a request off the web. Do we have valid data? It's binary. It's yes or no. It's either good or it's not good. So and this sort of error handling, it would be possible to write code to validate everything. This was a simple proof of concept. So I just took the approach that you've either given me something that's sensible and I'll process it, or you've given me something that's non-compliant and I'll report the first error that it finds. And this is a challenge when you pull in open source libraries. You have to assess how good they are, whether they support your requirements, and make choices therein. For me, when I was looking at it, I looked for well-supported libraries with a lot of current commits, multiple maintainers, and also did some vulnerability scans because that was procedure in my previous job. We made sure anything we pulled in didn't have any security vulnerabilities in it. So you have a lot of open source libraries available with C++, but you have to, if you're getting stuff for free, there's no free lunch. You have to make sure that what you're getting, you're happy with. Some of these libraries potentially we might offer support for on a paid basis, so that if you have a problem with the library, we can provide application support. Obviously, they're open source, you can get them for free. Any other questions? So here's some hints that go with using the Clang compiler. I should note that the Clang compiler is only available on x86 OpenVMS. And the operating system has a function name length of 31 characters. This is a nasty gotcha, because if you fail to do this, you'll have your linker will give you an undefined name and some fairly obscure messages about your error. And obviously we've got a bit of syntax if we want to specify C++11 standard. Absolutely necessary for the demo we've built. Now we should talk about addressing. OpenVMS, when we went to alpha, Digital at the time decided that they would, by default, have all the compilers work in a 32-bit address space programming. So be it the Fortran, the COBOL, the BASIC, the C compiler traditionally will give you 32-bit addressed objects now by default. Now the Clang compiler will give you 64-bit addressing by default. And if you try put the two together, you face some challenges passing data between the two. In my example, I actually made it work. If we jump back several pages, you'll see the make descriptor function had some magic in it. And you'll see that I'm making a 32-bit descriptor, and the operating system has a string descriptor. You can do it with a 64-bit or a 32-bit, and it's something to be careful with. And my basic advice is you don't want to be mixing 32-bit and 64-bit objects. You're making your life difficult and you're introducing risk and problem. So unless you've got a huge program that requires huge address space, 32-bit is probably easier. I'm quite happy to pass stuff between C++ and any of the legacy libraries. You need to read your COBOL or your Fortran manual quite carefully. So that, do you have a string descriptor? Do you have a reference? Hopefully you're familiar with the differences between passing by value, passing by reference. It's inherent. And obviously, if you're using C and pointers, you really do not want to be building them mixed mode, because you're going to have some nice undefined behavior. Let's see. I did some more digging about an investigation because I wanted more to have for this demo. I wanted to play with some of the Linux stuff for memory management, which is available in C++ 17. And every way I turned, I couldn't get it to work. And I raised a few JIRAs for our compiler team because we don't yet fully support C++ 17. And John Reagan, who's our compiler head, said, go ahead, we want to know what's wrong. So hopefully at some point in the future, we will be able to support C++ 17. I can't give you any timescales. So I played around with memory resources and addressing, and it was quite frustrating because I'm dealing with OpenVMS. I'm not dealing with C++ and Linux, and there's a limit to how much we can interface into the threading architecture on a modern CPU. And VMS traditionally has been a system that works with processors. And you may be able to do better than me. So there's a couple of notes down the bottom here that you have some special compiler and linker qualifiers if you want to put a multi-threaded application in. And this is a work in progress. So I would be contacting VSI customer support and asking about timescales if you really are wanting to work with the multi-threaded stuff. Most of the value of what we have is in old applications, and many of these will work multi-process, not multi-thread. So hopefully it's not an issue, but the short of it was I wasn't able to do anything that was a nice, interesting tool that I could demonstrate. So, any more questions? Many people here using much C++?
Yeah, I use it with the controllers.
Yep. Well, it is a very powerful, capable language that you can do stuff. Chances are nobody's going to start writing new applications with it, but there are wonderful things that we can do to link the old and add functionality, add new functionality. One of the other tools I've been playing with has been SQL Relay. It's presenting some really interesting options to build some tools. And the concept here is that if a customer wants to put a database, maybe Postgres or maybe SQL Server, we can put that out on a Windows system or a Linux system. We can use SQL Relay, which is a network product, and we can have a client code on OpenVMS that is connecting to a database, and that database is remote across the network. And that way, we don't need database drivers. I don't know what's happening with Oracle, and we're looking into tools whereby we can actually talk with Oracle, Oracle's and OpenVMS, and we can talk to a database somewhere else. So it's about having options. But,
if we build a new application from scratch for an x86 system, would you suggest to use the 64-bit instance services?
that depends on your requirements. If you're building new, are you building a complete new application, or are you building a new module or library to bolt into an existing? Once you come out of OpenVMS engineering and you go out into customer sites who are running applications on our operating system, you have a lot of existing functionality, and the first requirement is that you don't break anything. So it's great to do lots of new stuff. But if you're doing a new application, using the 64-bit library will be very interesting. I probably wouldn't recommend porting legacy code with 32-bit system service calls to 64-bit, because whoever IT director, CEO at the top of the company is going to say, oh, you're doing an exercise where you're converting from 32-bit to 64-bit. What financial advantage does that give the company? It's in the application world, we have to trade off business requirements and costs. But if you're writing a new application, by all means, I wasn't here to talk about system services, but I can. Does that sort of answer the question? Any other questions? And if you like the idea of web services and you don't have the skills in-house, our fair-sized professional service team are quite happy to spend a little time and help you on this journey if you want to go down extending and modernizing your system. If there's no more, shout if you've any more questions, and if not, we might as well wrap it up and have an early break. And my apologies that I didn't manage to put any more stuff in the demo, but I was really impressed with how quickly I could put this web server together and have it all work. It took me about a week to put the web server together. And the hardest part was actually remembering how to program in Fortran. Because I last used Fortran previously, I last used Fortran in anger in 1992.
That was interesting.
And thank you all for your time.
Thank you.